Hello, Luke. Welcome to lesson 26. So you may have noticed it's not lesson 25. We're actually skipping lesson 25, or rather, we're combining it with lesson 26. So lesson 25 and lesson 26 are both working with equations, and all we're doing is just kind of putting together a lot of the things that we've already learned and just making the equations a little bit more complicated. So rather than extending that into two lessons, I think we're going to make up on a little lost time here and combine the two lessons into one lesson. So this will be lesson 26. And again, we're going to be talking about equations today. And again, we're just combining some things that we've already learned. So let's just dive right into it here and start working some equations. So this first equation is similar to the ones that we've already seen before, except for now we're kind of combining a couple of the rules that we've learned in lesson 23 and lesson 24. So if we look at this, again, our goal is to get the variable, which in this case is x, all by itself, right? That's always the goal for solving these equations. Get x by itself. Now, there are a couple steps that we're going to need to follow to do that. And in previous lessons, they were restricted to just steps involving addition or steps involving multiplication or division. Now we're combining the two. So if we look at the left side of our equation here, we see that the variable x is being multiplied by the 3, but then it's also being added to the 6. All right, so two things are going on here. So to get x by itself, we need to get rid of the 6 on this side. We also need to get rid of the 3. All right, so let's start by just getting rid of our addition, and that's really where you're going to want to start always. At least in problems like this. Don't worry about this 3 coefficient here. We'll save him for later. Let's first just get this x term, this variable with its coefficient all by itself. And then we'll get the variable all by itself. So to do that, we need to get rid of this 6. And as we've learned in other lessons, all we're going to do is subtract 6 from both sides, right? To get rid of that 6. These will eliminate, and we're left with just our 3x. And then on this side, we have 18 minus 6, which is 12. All right? Now, in previous lessons, that was about it. That's where we were about done. But now we have another step. So now we still don't have x by itself. We're closer. We've got the x term by itself, right? But we don't have the x by itself. So to do that, we need to remember our multiplication rule. So if we have 3 times x, we want to get rid of that 3, so we're going to divide it by the 3, which means we have to divide this side by a 3. And if we do that, we get 3 divided by 3 is 1, so we get 1x, which is, of course, just x. And then 12 divided by 3 works out really nicely in this case, and our answer is 4. So the root, or the solution to this equation, is x equals 4. Now, if we wanted to go back and just check that, we could certainly do that. Let's rewrite this equation. We're just going to plug 4 in place of x, plus 6, and it's supposed to be equal to 18. So 3 times 4 is 12, and then 12 plus 6 is indeed 18. So therefore, this side is 18, which is equal to this side. Therefore, it's a true equation, and this is a solution. All right. So again, I hope you see that this is not anything different from what we've already done. It's just we're combining a couple different concepts. We're combining our addition rule with our multiplication rule to get x by itself. All right, so let's try another one here. So here we have kind of the same sort of setup here. Negative 4x plus 2 equals 18. Again, we recognize that there is multiplication and there is addition, and we're always going to start with the addition. We leave the coefficient until later. So we're going to begin by subtracting this 2 from both sides. These, of course, will eliminate, and we end up with a negative 4x. Don't forget that negative sign. Equals 18 minus 2. Well, that's 16, right? And now here, depends on your preference. You could approach this in a couple different ways. We could say, all right, so this is multiplication, so we're going to divide this by a negative 4. Some people just really don't like negative signs. All right. They lose them when they're working in problems, and they tend to get things wrong because they forget negative signs. So some people would actually prefer to, before they divide out this coefficient, this -4, first get rid of the negative sign. Just take an extra step and just get rid of the negative sign. And how could we just get rid of the negative sign? Well, if you think about it, and I'm just going to write this over here. If I have -4x equals 16. Now remember, I can divide or add anything to one side so long as I do it to the other. So let's just divide this by a -1. And that means I'd have to divide this side by a -1. Now, a negative divided by a negative is a positive. So a -4 divided by a -1 is a +4. And I still have my x, equals 16 divided by a -1. Well, a positive divided by a negative is a negative, so we end up with a -16. Now, notice what happened here. I just divided it by a -1, and all it did was change the signs for all the terms in the equation. So on the left-hand side, we lost the minus sign in front of the 4. On the right-hand side, we gained a negative sign because it was a positive, so it switched to a negative. The negative on the 4 changed to a positive. The positive on the 16 changed to a negative. So you can do this even mentally when you come across problems like this. You might even say, well, I just don't like the negative on the side that has my variable, so I'm just going to change this to a +4x, but then I have to change all the signs on the right-hand side, which means this is going to change to a -16. So do you see how that worked? All I did was just change the sign on this side, but then I had to change the sign on this side as well. All right? So you change the sign on one side, you have to change it on the other. Now, that brings us to a +4x, which a lot of people like. It's a little bit easier to work with. They don't have to worry about losing that negative sign. And now they can apply the multiplication rule to divide out this 4, right? And the 4s will divide out. We get an x, and we get a -16 divided by a 4. And this is a negative divided by a positive, so don't forget the negative sign. It's a -4. All right? So that would be our solution. Now, if you're a person that negative signs don't bother, well, then when we had it here, when we had this step, we could have just said, well, we have a -4x equals 16. I don't mind dividing negatives, so I'm just going to divide this out by a -4 and divide this side out by a -4. And the 4s will cross out. I'll still get a positive x because negative divided by a negative is an x, a positive. And then I have 16 divided by a -4, which is going to be a -4. So I could have still done this without switching the signs on both sides. Whatever is easiest for you. You can certainly get rid of the negative. Just remember to then change all the signs on the other side. Or you can keep the negative and divide it out as is, like I did here. Either way is acceptable. You'll find with equations that there are often many different ways to get to the same answer, which is okay. Whatever makes you feel like you're going to get fewer wrong, go with that approach. All right? So let's try a couple more here. If I've got -3x plus 12 equals -24, let's start again. This is a very similar problem. We're just going to get the x term all by itself, which means we need to get rid of this +12. So this will become a -12, or I should say we'll add a -12 to both sides. And then these will cross out, and we'll get a -3x equals, oh, sorry about that, -24 and a -12, which is going to be a -36, correct? All right. Now, here again, we have a negative on our variable side. We could certainly just divide this out by a -3, but you know what? Hey, let's get rid of that negative. So we're going to change this into a positive, which actually on this side, it's also going to change that to a positive because it was a negative also. And we end up with just positive answers, or positive coefficients. Now we can divide out by the 3, and we end up with x equals 12. And again, if we weren't sure, or if we wanted to make sure we got the right answer, we can go back to the top and plug in that 12 for the x. and make sure that it works out to be a true equation. So negative 3 times 12 would be a negative 36 plus 12. And a negative 36 plus 12, if you do the math on that, indeed that does turn into a negative 24. Which actually, whoops, this was supposed to be a negative 24. I forgot. See, I forgot my negative sign, right? But that works out. It's a true equation. All right. So let's try another one. Now we'll do one with some fractions. Fun. With fractions, we're doing the same procedure. It's just one note would be remembering to do that extra step of changing mixed numbers such as this 2 1/4 into improper fractions. It just makes it easier. You could do that now, or you could do it throughout the problem. We'll just do this one throughout the problem. So again, we're approaching this the same way. We have multiplication and addition. We're going to get rid of the addition first. So we're going to say a minus 1/2 minus 1/2 on both sides. These are going to cross out, and we're going to end up with a negative 3/4 m equals. Now here we have to first change this into an improper fraction. At least that's easier. So we have 9/4 minus 1/2, right? And if I find my common denominators here, I end up with 9/4 minus 2/4, which is 7/4. Oh, 7/4. Okay. So I end up with here a positive 7/4. Okay. Now I need to get rid of the coefficient. Now this would probably be a little bit easier again to get rid of the negative sign. So we'll do that. This is going to become a 3/4 m equals a negative 7/4, right? Because he was positive, now he becomes negative. Now to get rid of this 3/4, you can think of it as either dividing by 3/4 or multiplying by 4/3. I prefer to multiply by 4/3. It's a little bit easier just in the setup here. So we multiply both sides by 4/3. These will cross cancel and you get a 1m. And on the other side, well, we have a negative times a positive, right? So the answer is going to be a negative. We know that much. Now we can just multiply the fractions. We can cross cancel the 4s. And we end up with a negative 7/3, right? So our final answer is negative 7/3. All right. So hopefully this is becoming almost second nature to you now at this point. Let's try this one. Actually, if you want to pause the video and give this one a try, and then we'll do it together. All right. So let's solve this one. We have decimals in this case. And again, just think of them as just strange numbers. We have multiplication and addition. We're going to add this plus 0.4, which means we'll have to add a 0.4 over to this side as well. Now remember, when you're adding decimals, these ones of course will cross out. When you're adding decimals, the decimals have to be in line when you add them. So we place our decimals right below each other. Anything on the end here that just doesn't have anything under it, you can just put a 0 if that's helpful. All right. That doesn't change this. 0.4 is the same thing as 0.40. So now I can add these two up. 4 and 6 and decimal. So I have 0.3x equals 0.64. All right. Now I have to divide by a 0.3, right? We need to get rid of that 0.3 coefficient. So these will cross out. We get an x. Now we have to do a little bit of work here maybe. So we have a 0.64. And hopefully you remember how to divide out decimals, right? 0.3. We start by just moving that decimal over, right? So the decimal becomes at this spot here. And now we would have this 3 can go into the 6 twice. 3 can go into 4 once. And that's going to give us a 1/3, right? So it's 2.1 and 1/3, which is a nasty one. Now I could throw on another 0 here. Just to give a better decimal. Maybe we'll do that. Or you might remember that 1/3 is the same thing as 0.3333. So 3 can go into 10 3 times, and of course you get a 9. You could bring down another 0 if you want, and you're just going to keep going. It's because, again, 1/3 is equal to 0.33333 forever, right? So we end up with 2.133 going on forever and ever. Actually, we can just put this here. 2.133. Okay? So hopefully decimals aren't throwing you off. We haven't done a lot of work with decimals, so I'm hoping at this point that you recall how to work out those decimals. Okay? Excellent. Let's move on. So the next step here, we're going to start bringing more into the mix, more complicated and challenging equations. And they're going to look like this. So let's take this first one. And what we need to recognize is that it's still an equation, and it's just far more complicated, right? We have, in fact, like terms on the left and right sides of this equation. So when you're doing equations, and I'm going to maybe write this over here, the steps. So let's see, where's a good spot? The steps to doing equations. The first step is always to, I'm going to say, simplify. Okay, and what I mean by that is simply going to the equation, looking at just the left side, just the side, and just simplifying it, adding like terms, doing anything that you can do to this side, all right? And then once you're done with that, go to the other side and do the same thing here. Simplify this side, all right? And once you've arrived at a place where there is simply no more simplification to do, then we'll move on and start doing what we've done in these previous problems. All right, if you notice, all these previous problems, they were already simplified on the left and right side. There was nothing that we could have done on these or with these equations. Okay, so here though, there is some work that we can do. So I can, in fact, on this left-hand side, recognize that, okay, I've got 5x minus 3x plus 4. Oh, I've got some like terms here. I've got a 5x and I've got a negative 3x. Those are like terms. So I can combine those. So a 5x and a negative 3x, well, that's going to give me a 2x. Now I'm left with just a plus 4. And obviously there isn't any other like term. It's all by itself. So I'm left with the plus 4. That's as far as I can go in terms of simplifying this left side of the equation. All right. So now let's just place our equal sign and let's take a look at our right side. So over here, what have we got for like terms? Well, my goodness, we've got a 12, we've got a positive 2, and we've got a negative 6. In fact, all of these are like terms, right? So I can definitely simplify this. 12 plus 2 is 14. 14 minus 6, well, that's 8. So on this side, I end up with an 8, all right? So now my equation has been simplified. There's nothing else that I can do to the left or the right side. Now I can start to solve my equation. All right, and how do I do that? Well, remember, the goal is to get the x by itself. And to get the x by itself, we need to get rid of this positive 4 and this 2. And again, like I said earlier, we are first going to, well, maybe I should put that over here. The next step here. And actually, there is something else first. I'm going to skip that step. We're going to learn the second step later, but that one doesn't apply for this one. So I'm going to say the third step is going to be, let's see. Well, what's the right way to say this? I'm going to say isolate the variable term. All right. So in other words, that third step, which is in this case our second step, we want to isolate the variable term. So find the variable term, which is the 2x. We want to isolate that, get it by itself. So to do that, we are going to subtract the 4 from both sides. These will cross out. We end up with 2x is equal to 4. Then I might even say the next step here, maybe number 4, is to, if needed, I should say, really, uh, uh, we'll just say isolate the x. Oh, actually, it might not be an x, though. So we'll say isolate the variable. All right. So again, just to recap, we first simplify. Then for right now anyway, we'll skip to step 3, isolate the variable term. Okay. And then we isolate the variable. So we got the variable term all by itself here. Next step is to get the variable all by itself. And we do that by dividing by 2, right? And then we have our answer. Now we have x equals 2. Okay. So let's try another one here. I'm going to pause. I want you to pause the video and try doing this equation, and then we'll do it together. All right. So let's see how you did. We're going to start by simplifying the left-hand side, and we'll note that we have a positive 10 and a positive 4. They are like terms, so we can add those. So we have 14, and then we have what's left over, which is the minus 6x. Now on the right side, we've got a negative 2 and a negative 3. They can be combined. That would give us a negative 5, and we have a plus 3x left over. Okay? Now, this is where we get to that second step. So I'm curious to see how you did this on your own. Maybe you recognized it. But we've got an x here, we've got an x here. We've got x's on both sides of the equation this time, which is unusual for us. We've never had that before. So that brings us to step 2, which would be get all variables on one side. Okay, that's step 2. So we simplified. Now the step 2 is to get all the variables on one side. Okay, maybe, you know what, a better way to say that is going to be just get, because it's really only one variable. Let's say get the variable on one side. That actually makes more sense. Get the variable on one side. Okay. So again, we're trying to get the variable on one side. So you can decide which side you want the x to be on. All right. They're obviously on both right now, but which would you like it to be on? We could get all of the x's over on this side, the left side, or we could put all the x's on the right side. It's totally up to you. I like to move the negative x's over to the positive side. Again, it's sometimes nice just not to deal with negative signs. So if I have a negative 6x, I'm going to just say, I don't like the negative variable. Let's move him over to the other side. Now, how do I move him over to the other side? Well, the answer is pretty simple. To move him over to the other side, we're just going to add the 6x. If I add him to this side, do you see how that would eliminate him? A negative 6x and a positive 6x, well, that's a 0x, which is just a 0. So it eliminates him. But I have to add that over here then as well. And I'm going to write that right below its like term, its other variable, the 3x. Okay? So we can add these two sides. These will eliminate. So I've moved it out of that side. On this side, I still have the negative 5. But now I have this positive 3x plus a 6x, which is going to give me a positive 9x, right? So what I did is I just moved this 6x, this negative 6x, over to the other side, and it becomes a positive 6x, but I'm able to combine all my x's, and now I've got all my x's on one side of the equation, which is what I was trying to do. That's what I meant here. Get the variable on one side. Okay? So we have the variable on one side. Now the next step is to isolate the variable term. Well, now we need to get this 9x by itself. So we're going to add, I'll go back to my other color here. We're going to add the 5 on this side so that I can add it over here and get rid of it over here. Those will eliminate, and we end up with 19. And then over on the side, we still have a 9x. Okay, now the last step is to isolate the variable. So now we put the variable all by itself. Let's just divide it by 9, right? These will cross out, and I get an x equals, well, in this case, I'm just going to leave it as an improper fraction, 19 ninths. Now, this is the same thing as saying x is equal to 19 ninths. I can switch them, just, read it from the opposite side. That's totally fine. So I can write that as x is equal to 19 over 9. All right, so hopefully that makes some sense to you. All right, let's try some more of these. I'm going to pause the video, or I'm sorry, you're going to pause the video. Go ahead and try this equation next and see how you do. All right, so how did we do? A plus? Let's find out. So here, we're going to start by simplifying. Let's remember the first step, and maybe I should have done that before you did this on your own. I wonder if I can select here. How would this work? What if we just select all of that? And then if I come over here, maybe we'll put it here, down here maybe. And then we'll just erase this here because that we don't need. Okay. So there we go. Just as so that we can reference that. Okay. So those are our steps. All right, so the first step is to simplify both sides. So that's what we'll start with. What do we see here? Any like terms? Well, yes, we have a 3x and a negative x, right? That's going to give me a 2x. What else do I have for like terms? Well, I've got a positive 2 and I've got a positive 4. Those are like terms. So that gives me a positive 6, right? Now on the other side, what do we have? I've got a negative 5. And I've got a negative 4. Those would be like terms. So that'll give me a negative 9. And then I just have a negative x left over. So we'll leave him by himself. All right, so there we go. Now we've simplified. The next step is to get the variable on one side. And here we don't have it on one side. We have it on two sides. So in this case, again, like I said earlier, I like to move the negative variable if there is one. So here we have the negative variable. So we're just going to then add this x to both sides, and I'm going to add it right below my other x. Keep those in line, makes it easier to add them. These are going to cross out, and we're going to end up with a negative 9. And then over here, I've got 2x plus a 1x. Remember, there's that invisible 1 right here. So that's going to give me a 3x plus the 6. Now we're back to our much easier problems. We're going to minus the 6 or subtract the 6 from both sides. That's going to give me a 3x on this side. Negative 9 plus a negative 6 is a negative 15. Then I can divide both sides by 3. And that's going to eliminate. And we're going to have x is equal to negative 15 divided by 3 is a negative, don't forget the negative in this case, negative 5. All right? Just to make sure that I did that right, let's go back up. And we'll do a quick check here. So if I plug in negative 5 for all my x's, 3, negative 5, plus 2, minus another negative 5, plus 4, plus 4, equals negative 5, negative, and then I've got another negative 5 for that x, minus 4. Okay, so looking at it that way, I've got a 3 times a negative 5, and I'm going to make a little more room here, I think, if I can. There it is. Okay, so if I've got 3 times a negative 5, that's a negative 15, plus the 2, minus a minus 5, well, that's a plus 5, plus the 4, equals negative 5. Negative 5 is a positive 5, minus 4. Now over here I've got negative 15 and a positive 2 is a negative 13. Negative 13 and a 5 would be a negative 8. Negative 8 and a 4 is going to be a negative 4, if I did that all right. And over here I've got negative 5 plus 5. Well, that's going to be a 0. And then 0 plus a negative 4 is a negative 4. And negative 4 it is true that negative 4 equals a negative 4. So this is a true equation, and that means my solution is correct. Yay. All right, so let's try this one. Go ahead and pause it, and then we'll try it together. Okay, so let's see how you did. So we have to look for our like terms, right? So we have a z and we have a negative 4z. Well, that's going to give me a negative 3z. And then I have a plus 3 and a plus 7. Those are like terms. So that'll give me a plus 10, right? And then I've got my equal sign, and then I have 2z minus 5. Well, that doesn't have anything in there that's like terms. So that has to just stay the way it is, right? Now I can get my z's, get the variables on one side, or the variable on one side, and I can pick or choose. Again, I like to get rid of that negative, so we're going to add 3z over here, and we're going to add 3z over here. These will cross out, and we're left with just a 10. And over here we have 2z and 3z. Well, that's 5z minus 5. Now I can get my variable term by itself, and I can do that by adding the 5 to both sides. And 10 plus 5, well, that's 15. And these are going to cross out, and we end up with just 5z, right? Now I can get the variable all by itself. We'll divide both sides by 5. And that will give us z is equal to 15 divided by 5, which is 3. And I like to write that the other way around. Z is equal to 3. So that is our solution. All right, couple more here. We're going to be doing these until we can do them in our sleep. So go ahead and push pause and maybe try both of these. Give both of them a whirl, and then we'll do both of them together. All right, so here we go. Let's look for like terms. So I have a negative 7n, positive 2n. That's going to give me a negative 5n. And then I've got left over just a 3. So that just stays put. And then on my other side, what do I have? I've got a 4n, and I've got a n. So 4n and n is just going to be a 5n. And of course, I still have my negative 5. He's all by himself. All right, now let's move our variables over. So we're going to add 5n on this side and add 5n on this side. Oh, my. Sorry about that. That's better. So negative 5n and 5n eliminate, and we have a 3. A positive 5 and a positive 5 is a 10n minus 5. We can then add this 5 to both sides, right? And that's going to give me an 8 on the left side. These will cross out. We have just a 10n. And then we have to divide. So divide this side by 10. Divide this side by 10. And we have n is equal to 8/10, but that could be reduced. So let's definitely do that. Be reduced to 4/5, right? So my answer is 4/5. All right, let's try the next one here. All right, so let's go ahead and try this one then. If we look for like terms, we'll recognize first that actually we have parentheses, and we should really always do our parentheses first if we can. So let's rewrite this and just simplify those parentheses first. So I have a 3p plus 7. Now I have this minus 3, right? There's nothing that I can do inside the parentheses. That's as simplified as it can be. So a minus 3, that's the same thing as a plus 3, right? So we'll just write plus 3, and that just eliminates those parentheses. Now I have p plus a minus 2. Well, that's the equivalent of just p minus 2, right? Both of these, remember, all I'm doing is taking this negative and remembering there's that invisible 1 right here, right? So I'm saying a negative 1 times a negative 3, that's a positive 3, Here there's this invisible 1, and I have a positive 1 times a negative 2. Well, that's a negative 2, right? That's all I'm really doing here. I'm just kind of doing it in my head. So, but by doing that, we can eliminate the parentheses, okay? So now the parentheses are gone. Now we can look for like terms like we've done before. And we can recognize that we have a plus 7 and we have a plus 3. So that's going to give us a plus 10, right? And we still have our 3p, and we still have our equals p minus 2. Now we can subtract our 10 from both. Oh, I'm so sorry. No, not yet. So what's our next step? We want to get our variable all on one side. So we have a 3p here and a p here. Let's move that p over, and we'll just subtract this p from both sides. 3p minus p is going to be a 2p plus 10 equals, these cross out, and we have a negative 2. Now we can subtract that 10 there. And this is going to give us what? 2p. These will cross out. Negative 2 plus a negative 10 would be a negative 12. Now I can divide both sides by 2. P is equal to a negative 6, right? Because the negative divided by a positive is a negative. So P is equal to negative 6. And now, just to make sure that we did this one right, let's go back up, because we did a lot of work here. Let's go back up and just check it. And we can check it, remember, by just plugging in what our solution for P is and see if we get a true equation. So 3 times, we decided that P was a negative 6, plus 7 minus a minus 3 equals, and again, it's a negative 6 plus a negative 2. All right, so we have 3 times a negative 6, and I don't like this color. It's a little bit faded. Let's go with a brighter color. 3 minus 6 is a negative 18 plus 7 minus minus 3 is plus 3 equals a negative 6 plus a negative 2, which is just a negative 2. All right. Now we have negative 18 plus 7. Well, that's be a negative 11, right? And a negative 11 plus 3 is going to be a negative 8. And on this side, I have negative 6 plus a negative 2. That is also a negative 8. So, because it's a true equation, we know that this P is equal to negative 6 is a solution. Yay! We did it right. Okay? So, I think that's about where we're going to stop today. And again, just as a recap, it's pretty straightforward. All we're doing is combining things that we've learned about solving equations into just one equation. We're just doing it all at the same time. So remember, I would say the biggest thing to remember here is the takeaway here is that we need to remember these steps. So first, we simplify both sides, and then we need to get the variable on one side. Oh, one side. Somehow I lost the E. On one side. And then we need to isolate the variable term, and then we isolate the variable. All right? So if you can remember these 4 steps, these equations aren't difficult. There's just a lot of steps to it. All right? So very good. Good luck on the homework, and I will see you tomorrow.